You're now going to learn how you can solve a classification problem. A classification problem is where we take data and group it into buckets or categories. These categories can be good, bad, success, failure, admitted, not admitted. And these are examples of binary categories. That is, there are two categories. There are examples where you can categorize it into multiple buckets, high, medium, low, for example. But we'll be focusing primarily on how you can categorize into two buckets. This is something that you will learn without using any code, but you will learn how you can improve the quality of the models by choosing different parameters. Most importantly, all of these will be exposed as RESTful APIs. In other words, web page links that you can customize by just changing the link itself. To learn more, we're going to be playing around with an admission dataset. This dataset has information about 500 students who've applied for US universities, and we have the results of their GRE score, which is on a scale of up to 340, their TOEFL score, which can go as high as 120, their university rating, which is on a scale of 1 to 5, their statement of purpose rating, which again is on a scale of 1 to 5, but can also have half values, their letter of recommendation rating, their cumulative grade point average, whether they've done research or not. And on the basis of all of this information, whether they were admitted into a US university or not. So for example, Ethan was admitted into a US university, but Diana was not. And of the total of the 500, as many as 61 students were admitted, but the rest were not. This is a data set that we could play around with, expose as a microservice, and also see if we can create a machine learning application that can help predict whether a student actually got admitted or not. To expose any data as users, we use a microservice called Form Handler. You can find this by selecting Pages, expanding microservices, and choosing Form Handler, or by searching for Form Handler, and you should be able to see that directly. When you click on Form Handler, you get an interface under microservices that allows you to add an endpoint, which is the URL or the location at which this data will be exposed. Let's call this admission data. And we are going to add a data set to this. This data set can be given a name. Let's call it admission. And you can choose to either upload a file or connect to a database. There are several options for connecting to databases, but in our case, we are going to be uploading a specific file. That file is an admission data set that has details of whether the students were admitted or not. So let's take that, click on admissions, and select preview. What that does is shows us the details. So we have the first page, the second page, the third page, which has each of the columns that are there in the data set, their GRE score, TOEFL score, university rating, and all the way up to whether they were admitted or not. It's possible to perform several other operations on this, such as transforms, preparation, query function, modification, etc. But we're not going to do any of that. We are simply going to submit, and that adds admission data as a page here. When a form handler has been created, the output takes all of the data that was in the underlying data source, in our case, the admission CSV file, and exposes it as a JSON object. In this case, it is an array of objects that has each row and its column names as the keys and the values in the cells as the attributes. For example, the first row has Ethan Koch as a name, 337 as the GRE score, the TOEFL score is 118, and all of the other columns are shown in this form. This is only one of the formats in which the results can come from Form Handler. In the Gramex guide, you'll be able to see that Form Handler supports HTML, CSV, JSON, Excel, and a variety of other custom formats that you can create as well. Let's look at this in an HTML format. So we take this output and add the question mark format equals HTML query parameter. So it's question mark underscore format actually equals HTML, and that shows the same results as a HTML table. You can also filter this data. For example, if I only want students who have a university rating of 4 or above, I can say and let's copy the column name, that's university rating greater than or greater than tilde, which represents equal to. and that is 4. So anyone with a rating of 4 or 5 appears here. I can further filter this for only students who've gotten a TOEFL score of 115 or above. So that's, and TOEFL score greater than tilde is 115. So that's anyone with 105 or more, as well as a GRE score. Let's say, supposing I want only the people with low GRE score. Let's say anyone who scored less than 330 and GRE score less than 330. That gives us the people who've done well on their university rating as well as TOEFL score, but not so well in their GRE score. Now, if we further want to sort this by their CGPA, you can say and underscore sort equals CGPA. And that shows in ascending order the CGPA. You could convert that to a descending order by putting a minus in front of the CGPA, and that would sort in descending order of the CGPA. These and many other filters are inbuilt into Form Handler, and the set of all possible filters is mentioned in the documentation. What we've done now is exposed a data set in a way that can be read in the front end, either as a simple table or as a JSON format. So you can fetch this as data and pass them to charts on the front end to render them. And it is also possible to render this same data as charts from the back end as well. This is explained in the guide under the section Form Handler Charts, where for the same data, we can create the output as a wide variety of backend charts. In sum, what Form Handler does is converts data into a REST API without the need for any kind of programming. Now let's predict whether a student will get admitted into a US university. And we'll do that based on their research, CGPA, and other scores for each student. To do this, we're going to use ML Handler. ML Handler stands for Machine Learning Handler, and it allows us to make predictions either by classifying the information into categories like whether they will get admitted or not, or using regression where we will forecast what is going to happen based on other parameters. Let's put this at a URL called, let's say, admit data, and we'll upload the data set, which is the admission file that we just saw. It has the student's GRE score, TOEFL score, and other parameters, as well as a final parameter of whether they'll be admitted or not. The next thing we need to do is choose a target column. That is, what do we want to predict? We want to predict the admitted column, which is either 0, which means they're not going to get admitted, or 1, which means they're going to get admitted. Are there any columns we want to exclude from this? Well, we do want to consider GRE score, TOEFL score, and all of those. But maybe we don't need the name because it's unlikely that the admission process will use the student's name for deciding admissions. So that column gets excluded. Are there any categorical columns? Are there any numerical columns? Well, almost all of these columns are numbers, so it may be safe to select all and choose every single column as a numerical column. But it's also fine to choose a column like research as a categorical column because that seems to only have 0 or 1. So I'll select research in the categorical list and remove it from the numerical list. There is an option to choose transformations, an option to pick several models. We are not going to do any of that. Let's just submit and see what happens. We have a microservice now called ML Handler. Let's see what the output looks like. To begin with, we have the same data that we had uploaded for each student, their GRE score, TOEFL score, and whether they were admitted or not. The parameters that we've entered, which is the target column, columns to exclude, etc. And we also additionally have a choice of metric to figure out how good the model is. There are multiple metrics such as balanced accuracy, ROCAU, CF1 score, but we'll just stick to the default of accuracy and then see what the results look like for different models. For example, if we choose the logistic regression model, which is the first one on the list, there's a 97.2% accuracy, which sounds good. Let's take the next one, the Bernoulli naive Bayes model. That gives us an 87% accuracy, not as good as the earlier one. Perceptron, when we train it on this data, gives us a 97.4% accuracy, which is slightly better. And we could cycle through these and eventually converge on decision tree classifier, which has a 100% accuracy, meaning it's able to fully predict all 500 rows with no errors. How exactly do these predictions work? Out here, we have the scores for Ethan, a 337 in GRE, 118 in TOEFL, and so on. If we click on predict, it predicts that Ethan will get admitted. But if we enter details for, let's say, Diana, whose GRE score is 324, whose TOEFL score is 107, whose university rating is 4, whose SOP is 4, whose letter of recommendation is 4.5, CGPA is 8.87, and who did research. Will she get admitted? According to the data, no. And according to the prediction, no. So what does Diana need to do to get admitted? Would it help if she had a perfect GRE score of 340? Let's test. And yes, if she had a perfect GRE score, she would get admitted. Does she need a perfect GRE score? Would 330 suffice? No. Does she get through with 335? Yes. What about 334? No. So it looks like she needs to score at least 335, and her score has to go up from 324 to 335. That is 11 more on the GRE score for her to get admitted. But is that the only way for her to get admitted? Let's take it back to 324 and see what happens if she increases her CGPA to a perfect 10. She does get admitted. So if she could get a perfect 10, she will get admitted. But does she need that? What if it were, let's say, 9.5? No. 9.6, that gets her through. 9.5, that doesn't get her through. 9.55, that gets her through. 9.54, that doesn't get her through. So she needs a 9.55 CGPA to get through, up from her 8.67. And there may be other ways, but Diana has to now decide whether it's going to be easier for her to go from 8.87 to 9.55 on CGPA, or from 324 to 335 on her GRE score. This is an example of how the models can be used to identify and help influence behaviors so that people can make decisions based on the underlying insights. Let's explore what happens behind the scenes in ML Handler. To do that, we'll press F12 to go to the developer tools and specifically choose the network tab within that. This shows us all of the requests and responses made by this page. When we click on predict, what it does is sends a request to /admit data with a series of query parameters. The GRE score of 324, TOEFL score of 107, etc. are all sent as part of the URL itself, taken from what you see on the page here. While this is the input payload, the response comes through as a JSON object. This is the raw response, and it has let's look at this again, GRE score, TOEFL score, etc. as specified, as well as an admitted, which is the result of the calculation. If we change this to, let's say, 335 and click on predict, that sends another URL with the revised GRE score. That's also part of the response, and it gives a revised admitted result. In other words, it's done the calculation and predicts that for these scores, the student will be admitted. You can open this in a new tab and see the results. You can play around with it. What happens if instead of 335, it's 334, and now Diana will not get admitted with this score, and so on. Using this, it's possible to create a front-end application that can send requests using such a score and get the response and display that response.